By now this should be a familiar physical setup. We have a solution containing different metal cations, and we're adding a salt that slowly increases the concentration of an anion that leads to an insoluble salt. In this case, we have silver, magnesium, and aluminum ions present in solution. All of them have insoluble hydroxides. So we're increasing the hydroxide ion concentration by adding sodium hydroxide. Eventually, for each salt, we're going to reach a point where the IP is equal to the KSP. At that point, the solution is saturated in that salt. That's an equilibrium situation. If we continue to add hydroxide beyond this point, IP is going to exceed KSP, and that salt will precipitate. Because these salts all dissociate differently and they all have different concentrations of the metal cation to begin with, we will need to solve for the hydroxide ion concentration required for IP to equal KSP for each of the three salts. Here we've solved for the hydroxide ion concentration required to produce a saturated solution of silver hydroxide. Here's our dissociation reaction and the associated KSP expression. Once we have this expression, we can solve for the hydroxide ion concentration. Again, this is a hydroxide ion concentration required to produce a saturated solution of silver 1 hydroxide. If this hydroxide ion concentration gets any higher, silver hydroxide will precipitate. Now, before we go on and do the other salts, I wanted to make a point that we do not need an ice table in this problem. The salt source of the hydroxide ion is a sodium hydroxide that we're adding. It doesn't come from silver hydroxide, so we're not going to have an ice table for any of these salts. Here we've solved for the concentration of hydroxide required to precipitate the magnesium hydroxide. Again, we don't need an ice table because the hydroxide ion concentration here is coming from sodium hydroxide, not the dissolution of this salt. So we solve directly for this hydroxide ion concentration, and we get 2 times 10 to the minus 5 moles per liter. So the magnesium hydroxide here is going to require a higher hydroxide ion concentration than the silver hydroxide. All right, and here we've solved for the concentration of hydroxide required to get a saturated solution of aluminum hydroxide. Here's how it dissociates. We have the dissociation reaction so that we can appropriately write the KSP expression. Solving for hydroxide requires us to take a cube root of this quotient. When we do that, we find that we need 3 times 10 to the minus 5 moles per liter of hydroxide in order to cause aluminum hydroxide to be in a saturated solution. Now, finally, we can answer the question. The salt that will first precipitate is going to be the silver hydroxide, because it requires the lowest concentration of hydroxide to achieve a saturated solution. Then once we've achieved a saturated solution, continuing to add hydroxide is going to cause the salt to precipitate.